as soon as we get started here. Okay, we are now live. Yep, now I've got sharing back. So you guys should be seeing my screen. Okay, everybody see that?
Yeah.
Okay, so here's the agenda for today. Once again, I do apologize. I don't know what happened. I shared a screen to one of the students and then I unshared it. I must have unshared it the wrong way and I could not reshare. And we were kind of hamstrung without me being able to share. Anyway, here we go. Here's the 5 things I wanted to do today. Even though we've done this a bunch of times before, I wanted to see if there were any questions on the review, see if anybody has any questions from last time. I didn't spend very much time on the symmetry tests, so I want to spend some time on that today. I thought we could do a few more circle problems together, and then I'll give you the assignment. So that's kind of the plan of attack today. So let's open it up to questions on the review.
I had a question about 38B once.
38B?
Yeah.
Okay, let me try to find that. So this is the P review number 38B. Okay, I'm getting there. Yeah, that cube root.
The B part, which is like a root to the 5th.
Oh yeah, you're right. I see that, a 5th root. Okay. So this is a review. (38B). Okay, we have the 5th root of 64 x to the 6th.
Yeah.
Try to think, when we simplified square roots, what did we always try to do? We tried to factor.
Right.
And now this time we want to factor, but this time we want perfect quints. That is perfect numbers to the 5th power. Welcome, Jack. So, what's 1 to the 5th? That's 1.
1 to the 5th power.
Jack, you might want to mute Jack. They're having problems with feedback here.
Oh.
Anyway, 1 to the 5th is 1. 2 to the 5th is what? 32?
Yeah.
Shouting back at myself here. Sorry about that. Jack, you may need to mute. Since you joined, you've had a little feedback problem. Jack Murphy, could you please mute? Okay, oh, I'm sorry, he went out. All right, well, anyway, can all of you see that this is 2 to the 5th?
Mm-hmm.
So, could I get 32 to be a factor of this? Yes, I could. So I'm going to rewrite this as 5th root of 32 times 2 times x to the 5th times x. So I still have what I had originally, but I've factored it so I have 2 perfect what? So to speak, there is no such name, but 2 perfect quints. Now, I can take the 5th root of 32 out, that's 2. I can take the 5th root of x to the 5th, that's x. And then what is still remaining under the 5th root sign? The 2 and the x. And we're done.
Okay. Thank you.
The only difference is when you're doing square roots, you want to get all those perfect squares as factors. Now we need perfect 5th power numbers when you're doing a 5th root.
Right.
Okay, other questions on the review?
Yeah, number 60.
All right, 60 on the review. And I see I'm getting other review questions here. Number 42. Got it, everybody. Okay, 42, I'm going to take 60 next as someone just requested. All right, number 60. I got to be careful here. I'm not supposed to be doing them exactly. What I'll do is I'll just start them. Okay, review number 60. So we've got wow, 84, 94 are also requested. Okay. I'm watching those notices come up on the screen. You can see them too. Okay, what's the rest of 60? Times x plus 2. So you just basically have to do what? The handshaking routine. So first you're going to want to take x times x. I'm going to just write it in this raw way. Plus, and then you're going to take x times 2. And then we've got plus negative 1 over x times x, and then plus negative 1 over x times 2. Right? There should be 4 handshakes. So do you see how that would be the raw? Okay, now, of course, this is x squared. This is 2x. What is this next term? What's negative 1 over x times x?
Is it negative 1?
Yep. And then that last term, negative 1 over x times 2, about all you can do is, there's nothing that, nothing cancels. 2 is basically on the top, right?
Yeah.
So, really, you don't have any like terms to combine here. This term that I just circled is not alike to that one. So, you pretty much would have to leave your answer in this form.
Okay.
Okay, the next one I have, somebody asked about is 84. Okay, so 84 on the review coming up next. Review number 84. All right, looks like we have a subtraction of fractions problem. Okay, we can't subtract right now because we do not have a common denominator. What we need to do is explore if we can factor this thing right here, right? So just rewriting it. Can't do anything with that one. You can't really factor that numerator either, can you? Now here we could try what? 2x in one factor and x in the other. It's a little bit harder to factor. 2 and 1. And the positive has got to be over here. So now just check. The inner factor, negative 1x, the outer, positive 4x, and negative 1x plus a positive 4x is a positive 3x, so we have it. Okay, now I'm not going to finish this, but we still don't have a common denominator. But now I can see what I need to get a common denominator. The second fraction, we're all set to go. What does the first fraction need? A 2x minus 1. So the next step would be to multiply the first fraction top and bottom by 2x minus 1. That will give you a common denominator, and then you should be able to proceed, combine I'm not going to go any further than that. So whoever asked for 84, is that helpful? Whoever asked for 84, is that helpful? Well, okay, I'm hoping it is. I had a request for 94. So please note, I did not finish this one intentionally, okay? Next, next request I have is for number 94 on the review, so let's take a look at that. All right, number 94. So we have a T. Oh, we got a request for 86 too. Okay, I didn't expect this many. I take it everybody is going big time. Oh, okay, and I got a yes answer. Good. I take it everyone is going at this big time, the assignment, maybe bigger than up until now, because of course it's due tomorrow. And then times some quantity over here. Okay, I think I have it copied right. There's number 94. Let's just discuss this briefly. Well, what you want to do is work on the left side. And after working on the left side, you'd like to come up with something that when multiplied by this fraction on the right side, you know, whatever that box is, what needs to be multiplied by 1 over the square root of t, you know, t plus 1. So really, here's where you need to do your work over here. And I can't subtract those right now because we don't have a common denominator. 42. Okay, yeah, you're right. I forgot about 42. I will get to it. Thank you. Thank you, 608-577-8901, whatever your name is. Got it? Sorry, I forgot. So right now, what's the denominator? What kind of a situation? Really, the second fraction currently has a denominator of 1, right? What do we need it to be? If we're going to subtract these two, this has to have a square root of t plus 1. And so I'm going to multiply the top and bottom of this second fraction by the square root of t plus 1. So what does that give me on the left side? Do you see that I have my common denominator? Okay. What happens, you know, what happens right here when you do this multiplication? This one right here, when you multiply those two guys, what happens when you multiply a square root by itself? You get that thing without the root sign. So you get t plus 1. But please note, that whole thing is being subtracted, right? Okay, I've gone too far. I'm not going to go any further. I've just about handed this one to you. Sorry, it's so much fun to do these. I go too far. Okay, that's 94. Now, lest I forget, let's take a look at 42. You're not going to be real happy. Several people have talked to me about 42 privately. Let me just maybe, and I don't know how much we can write, but I'll get started here. So this is review number 42. Okay. They gave you, all right, do you guys all get that? You're looking at the cross section in that picture. Okay, that's the cross section. And they gave you the width. It's 8 times the square root of 3. They gave you the height. It's that square root of 24 squared minus 8 times the square root of 3 squared. How do you find the area of a rectangle? Take those two dimensions and multiply them to get, you know, length times width. Okay. Well, I mean, all you got to do is multiply and simplify. So what can you do to simplify that h thing? Here, let me just write that out. I mean, this is just basic computation. What's 24 squared? I mean, you guys can figure that out. Is that 576? I'm going by memory. Yeah, that's 576. Now, what happens when you square 8 times the square root of 3? Well, you got to square the 8, and you got to square the square root of 3. What's the square root of 3 squared? 3. So this part is 64 times 3. I mean, then you guys can go ahead and do the arithmetic. All right, now all I'm doing is simplifying h. When you're all done, you got to take whatever this turns out to be and multiply it by what? The width. I mean, that's all there really is to that one. I'm not sure why that gave people so much grief. It's really just kind of basic algebra stuff. Anyway, that's about as far as I can go on that one. Thank you, and I'm sorry to all of you who requested 42. I don't know why. I had it on my paper. Okay. So what was the second item on the agenda? I got to just go back here and take a look. Yeah, are there any questions from last time? I'm guessing not a whole lot because we didn't quite get done, but remember we used the Pythagorean theorem. We talked about this new standard equation for a circle. We talked about symmetry. Yeah. So, okay, I'm going to go to these symmetry tests. So let me find my way here. Okay, now last time I demonstrated to you the 3 types of symmetry. Do you remember? There was y-axis symmetry. That's when if you folded the curve vertically, you would get a matchup. You know, y-axis symmetry looks like, that's this one right here, looks like this. You know, it's some curve, like a parabola, that's not very good, but when you fold it on the y-axis, you would get the same curve. And then there's x-axis symmetry, which looks like this. You might have again, a parabola. This time, if you folded the graph on the x-axis, you'd have that. And then the third one I demonstrated to you was kind of like, this is a cubic function. That's called origin symmetry, so that pick any point on the graph, you'll always have a matching one that is equidistant away on the other side. You know, here's another point. It's matching one. So the line that connects them always goes through the origin and is bisected. So we discussed those 3 kinds of symmetry last time, but what I didn't talk to you about is the tests. So let's look at this list here. So, and I'm going to take number 2 first because it's the most common. A graph is symmetric with respect to the y-axis if for any point xy, the point negative x, comma y is also on the graph. So here's how I would word that. If you can plug a point into a graph and then change the x-coordinate, change the sign of the x-coordinate, and it's still on the graph, like right here, this could be, let's say, 2, 0. Well, if negative 2, 0, see how I kept the y-coordinate the same and all I did was change the sign? Guess what? That tells me we have y-axis symmetry. So the test for y-axis symmetry is, if you can take a point that works, change the x-coordinate sign, and it still works, then you've got y-axis symmetry. Conversely, let's go to number 1 now. I'll change colors so we don't get too goofed up. That would be this one, x-axis symmetry. Now, you got a point on the graph. Let's say, what is this? I don't know, -1, comma 2. And you keep the x-coordinate the same. This time, just change the sign of the y-coordinate. Are both of those on there? Well, then you've got x-axis symmetry. And the third test, to find out if you have origin symmetry, this time, all you need to, you change the sign on both of them. So for example, this point here, is -1, comma -1. So what's this matching point here? Oh, it's +1, comma +1. So in other words, on this one, if you pick a point that works and change the sign on both coordinates at the same time, and if that point's on it, then you've got origin symmetry. So these come in real handy. So if I give you a raw equation, and I think they do this on the assignment, they just give you an equation. Real quickly, you can test and look. So here, I can't show it on the screen, but you guys peek ahead to page 86. And if you look at, you see that section from 25 to 36? Okay, look at number 36. Okay, we have x equals y squared minus 5. If you can you change the sign on x in number 36 without changing the rest of the problem? No. If you multiply the left side by -1, that means the right side is going to be reversed, and instead of y squared minus 5, it's going to be 5 minus y squared, and you're going to get different. So what I'm telling you is you can't change the sign on x there. So that tells me that this thing can't have y-axis symmetry. How about y? Could you plug in, let's say, a 2 and plug in a -2 and get the same result? Yes, because +2 and -2 squared both equal the same thing. So that one's going to have x-axis symmetry. So I don't know, you can see how you can start using these tests. By the way, if 36 didn't have x-axis symmetry, then it sure can't it's got to have both in order to have origin symmetry. So we don't even bother looking at that. So one more time, number 36 does not have y-axis symmetry. It does have x-axis symmetry. And because it only has one of those top two, it can't have number 3. So what you need to do, I didn't spend any time on that last time. You'll see these tests. I took this right from your book. That particular thing is on page 81. And you should take a look at that, and we want to become familiar with that because it can save you a lot of time. Once you know what kind of symmetry it has, it can help you a lot with graphing. Okay, that was the symmetry part I wanted to share with you. Now I want to talk about circles one more time. So do you recall last time that we talked about the standard form of a circle, which I'm going to write at the bottom of this screen? Do you remember we wrote this? And I put that in a rectangle, and I said that's the standard form of a circle whose center is at h comma k and whose radius is r. We put that in a rectangle, remember that? And then we applied that. We did some in class. Well, here's another one to do. If you were given that the center of a circle was at 4, -3, and its radius is 2, could you write the equation? Yeah, because we know the center. We know h is 4. So we subtract it from x, x minus 4. We know k is negative 3. What happens when you subtract a negative 3? It becomes plus 3. And then the radius was 2, so r squared is 4. Okay, that one on the bottom there is something else. Oh, well, let's do that one. All right, let's look at this one now. Is that a circle? It does fit the form at the bottom of the page, right? So what is the center of that circle? 4, 3/2. And what is the radius? Well, you're looking at r squared over there, 64/9. So what would be r? 8/3, right? Okay, so you want to get good at going backwards and forwards with that. That completing the square I showed you, that'll be coming up not so much in this assignment, but yeah, not too long in the future. Here's a couple of questions from the book, from the assignment that's coming up here. I copied these right from the assignment. Maybe let's just practice. I don't know. Let's take number 56. Can you find the equation of a circle whose the endpoints of the diameter at -4, -1, and 4, 1? What? They didn't give us the center and they didn't give us the radius. Or did they? If you know the endpoints of a diameter, how can you find the center?
Midpoint formula.
Right, and what's the midpoint of this? Average of the x squared, -4 plus 4 is 0, 0 divided by 2 is 0. -1 plus 1 is 0, and that divided by 2. So in other words, here is your HK. All right, and how are we going to get the radius? Now this one's a little bit trickier. If you know the center and you know the endpoints of the diameter, how can you find the radius?
Distance formula from the center to one of the endpoints.
Right. So do you see how you got a little bit of work to do on a problem like that one? Okay, so just little twists. I mean, they start off really easy, 49. They give you the center, they give you the radius. Man, you can write that equation directly. Then they changed, make the center a little bit harder in 51. Okay, no big deal. Now, let's talk about 54. What's different about that one? They give you the center. Well, that's cool. So we know H and K. What does the solution point mean? That means that's one of the points on the circle. Again, what's missing? The radius. Well, if you know the center and you know one point, just like Brandon just said, can't we use the distance formula to find r there? Yeah. And don't forget, when you write your equation, it's r squared you want, right? Just a quick repeat here of this slide. You know, it's x minus h squared plus y minus k squared equals r squared. So don't forget, you want to put r squared there. Somebody have a question? Go ahead. Okay. I'm going to go to the assignment. And by the way, these are posted online. Remember, if you go on our Moodle page, if you look at the bottom of lesson 1.1, you'll see, in fact, that's where I copied this from. So you can tell the assignment is this every other odd thing. 1, 5, 9, and so forth. Questions? Once again, my apologies for having to restart you in the beginning. I lost my sharing, and if I don't have my sharing, it would have to all be by speech, which is pretty impossible with math. So thanks for putting up with that. Questions, one more time. Let's take another take on that. Anybody by text message or just plain speak up and ask a question? All right, then I will see you in class tomorrow. Thank you. Have a good one. Yeah, just a minute, Mark. Just a minute.